Hi guys, my name is Wolfgang Dobler. I did my PhD in hydraulics, and here in the company I deal mostly with project work and software development.
My name is Werner Benger. I am the technical director of AHM and the software architect for Hydrofish. My specialty is the scientific visualization of big data.
Hi, my name is Ramona Baran and I'm responsible for project management and data acquisition at AHM.
My name is Wolfgang Leimer. I am software developer and my tasks are data I/O and data processing.
Hello everybody, I'm Frank, I'm the CEO of AHM. I'm really sorry to meet you not all in person during the ILMF in Washington, but that's the case now, that's the situation. We are today reporting directly from the quarantine here in Tyrol, Austria. It's a pleasure for us and we are really happy to have the possibility and the chance to give you our presentation during the Riegl virtual conference. We wanted to celebrate with you together our 10th anniversary. We started about 10 years ago together with Riegl for the topobathymetry tasks and issues in the near future. And we made it now 10 years and we wanted to celebrate our approaches and what we have reached within this 10 years together. If you have more interests in what are the chances and the pitfalls in full waveform and lighter data processing, also have a closer look in the actual version of the Forbes magazine. We got an article there. It will be a pleasure to provide this to you. And now enjoy our presentation and thanks to all from Austria and especially stay safe. So hello again, now in person. Let's start with our presentation. Processing of full waveform data for topobathymetric LiDAR datasets within our software Hydrofish. As already mentioned within my short speech, we have now 10 years of AHM. Together with the Riegl, we started about 10 years ago the development of the topobathymetric LiDAR series of Riegl. And our company is mainly dedicated for topobathymetric data processing. So as mentioned, founded in 2010, we are focused on topobathymetry and also on geomass data processing, which is coming automatically if you're thinking about using green LiDAR and the topobathymetric system. And the further purposes within our company for sure is into the analysis of the data, especially related to hydro and ecologic purposes. We have now made within the last 10 years more than 400 satisfied customers by using just Riegl products. We started with the breadboard system of the 532 nanometer sensor, then we went into the VQ820G, and right at the moment we are operating the VQ880G series. And just to give you a short impression, our largest project we have right at the moment by using the sensor is over 42 terabytes of RXP data just within one single project we have to process. And here you can already see how important it is to have a quick and especially efficient step into data processing. So what's going on with AHM? For sure, we want to inform that also from our side, the focus on, let's say, ecologic oriented survey is very important for us, and therefore we invested in 2020 now into a new fixed wing flying platform. It's from Technam, it's the Traveler P2012. With this new platform, we have totally new possibilities for our customers and clients here in Europe. And from my point of view, next to the possibility to have 2 large hatches for the operation of 1 more Riegl sensor in future, from my personal point of view, also interesting is that it will be the first operating platform, the first operating sensor platform, which is totally driven by renewable aviation gasoline. So we have set up within the research project our own production site for renewable aviation gasoline, which is making out of solar, out of wind, let's say the power for our engines to operate our mission platforms. Our presentation, but for sure is set towards the possibilities, the tremendous and amazing possibilities you have within full waveform processing by using the Riegl data.
From our point of view, this let's say this data, the full waveform data, is somehow, let's say, not used or taken into account due to the large effort in data processing. But what we want to show within our presentation, don't be afraid of. Take the chances, go into the analysis, into this data. The outcomes are amazing. Just have a close look. And therefore, we wanted to introduce 3 short projects, and the largest full waveform data processing project we are right at the moment working on is the survey of the River Elbe. It's more than 600 kilometers in length. We are talking about 8 terabytes of RXP files. And we have to process within this project the point cloud coming from the online waveform processing, but also from the full waveform processing, to improve especially the penetration within this project. Because for sure, what you can imagine, given to the fact that we are talking about 600 kilometers in survey, we have definitely, or have had definitely, changes in the mission related to tidal influences, related to clear versus turbid sections. We have had different soil conditions. We have had different areas of subaquatic vegetations, and they have all influence in topobathymetric measurements. And therefore, we have seen the possibility and the chance, by improving this data set further, in going into full waveform data processing. So what is definitely an outcome if you invest into full waveform data processing is you will see a deeper and a better penetration, which will definitely increase your spatial water ground coverage. You will have the possibility to evaluate the water conditions, especially in terms of turbidity. And also you have the possibility to evaluate ecologic aspects, for example, underwater vegetation, but also which kind of soil you have measured there underneath the water surface. So just to give you a few quick impressions, deeper penetration. The other picture just shows you the data set coming out for the River Elbe based on the online waveform processing, and the image below, all the red points, are indicating the additional points we were able to extract of the recorded full waveform data from the Riegl sensor by full waveform processing. Furthermore, as mentioned, we have had different tasks within the survey, from clear to more turbid conditions. By using the waveform and by using the evaluation of the E-fitting curve, you're able to determine the turbidity factor within the water column. And also the aspect or the chances in the evaluation of let's say, to get a deeper insight in what's happening with the underwater vegetation situation can be improved by using the full waveform data sets. So how does the full waveform processing possibilities work within the software? So we're starting from a kind of data merging and visualization of the online waveform processed points and the full waveform signals within one data set. For us, it's very important to provide the user a visual access to the waveform, because each covered data set, each covered topobathymetric data set is different. And therefore, the user has to investigate what is the right approach to go into full waveform processing to get the best outcome. And we have seen this is the best possible way to do it on a visual approach, directly to see the waveform on the captured online waveform processed point cloud. So within the further steps of the software, we have the possibility to go into a flexible full waveform analysis, for example, peak detection using the E-fitting function, go into waveform stacking, even into deconvolution. And from our point, also very important to just have the possibility and to see this massive amount of data coming from the waveforms in real time, in situ, on the point cloud, on the data you have processed. So how does this look like? So within the software, you see to each dedicated point the visualization of the shape of the waveform. We have, or you have, then the possibility to set up different visualization types on the waveform to give you a better possibility into the interpretation of what you're seeing there. And here you now see, for example, a cross section over the river. And all the blue dots you're seeing here are the points coming out of the online waveform processed data. And the other things you're seeing here are the dedicated waveforms for each laser shot shown within this cross section. So especially here in the lower part of the cross section, you see that you're losing the ground information due to not clear detection of the water bottom coming from the online waveform processing. But you already see here by only the visualization of the full waveform, there must be more in the data set that you can see, okay, this is the clear distinguished shape of this water bottom here within this area. So in our presentation in real time, we wanted to show you how quick and easy access the data is possible to give to you. We just have here a data set from the River Rhine. By just jumping to this website, you find the possibility just to download the software and test it within your own waveform data coming from the real sensors. Very important, we gave all the processing to make it very easy for the users, GUI assisted processing chain. It's really easy to understand, and also the help is, let's say, quite good documented, right? So this is really now the real-time processing of this River Rhine dataset. Here in the left upper window, you see the start now of the processing of the RXP files for the dataset. You see in the lower video now running here and already visualized. So the entire processing of this dataset took a little bit more than 2 minutes. So with the video, I just want to provide you a little bit more insight in how the visualization is looking like. So as mentioned here, all the blue dots you're seeing, these are the points coming out of the online waveform processing. And let's say this orange or brown colors you see here is the visualization of the waveforms. Very important to know and to understand, full waveform processing doesn't only improve on the bathymetry side, also on the topography side, you have an improvement. For example, here in this area, you see that no online waveform points are detected, but the waveform provides you further information of bottom points which are lying underneath the vegetation in this area. So as mentioned, the upper part, the processing is still running. The entire processing chain you need to be performed from the raw files to the final point cloud are done within the software. So yeah, feel free to test it and also to get in contact with our engineering team to give you a better impression about the possibilities within the entire full waveform processing chain. Yeah, we've almost made it. Right at the moment, the full waveform data set and the generated point clouds are refragmented in a way to better visualize this huge amount of data in real time afterwards. So seen here. As mentioned, feel free to test it. The entire process chain is given, and this 1 GB RXP file we have seen right at the moment took about 198 seconds. Okay, it's a little bit more. It's about 3 minutes we are talking here about for the entire processing of this dataset, including the waveform analysis. And how does this waveform analysis improve the results coming from the Riegl sensor? Here you see the online waveform point cloud, and you see that although we have already a quite good bottom coverage, you see here a leakage of data or gaps in detail. Now we overlay this data with the full waveform in detail, and once more here you can already see there is an additional information in the waveform. So our task now is to extract this information out of the waveform. Therefore we have for sure different approaches. As mentioned already in the short video, This improvement does not only work underwater, it also works within dense vegetated area. In comparison, left on the waveform process data set, on the right, the information additionally coming from the full waveform overlay here. But what is now the, let's say, right technical approach in data evaluation and in full waveform processing? And therefore, from our point of view, it was very important to give you and provide you visual input for the further steps in data processing, which makes it easier for you to decide what processing chain for extracting the information out of the waveform is the right way. So you have the possibility to go just into peak detection, into an e-fitting, in waveform stacking, or as mentioned also in deconvolution. Very important to know and to understand that we have implemented a variable threshold in peak detection for improving the results, especially if you're going deeper within the water column. The e-fitting function is a great approach in improving the automatic classification of topobathymetric data sets. So first, the position of the e-fitting curve is distinguished, and based on this, the system is very good possible and able to divide the data set into no water body coming from the last full waveform peak after the e-fitting position, and the water body itself coming from the first full waveform, or the water surface coming from the first full waveform after the e-fitting position. It also helps you to calculate the damping coefficient. These are some values sometimes important for our clients we have here, especially related, let's say, the maintenance of water bodies, and also related to the evaluation of the analysis of the ecological situation of the waters. And furthermore, for sure, you can go into wacking. Waveform stacking is done under different search criteria. I didn't want, related to time, dig into deeper to this. It's just a further approach you can use, but you have to decide what is the right approach and going into the full waveform analysis to get the best results out of the data sets you have. For example, the test data sets here, or the test data set we have here at the River Rhine, we have decided that just a simple peak detection is sufficient in results for a better ground and bottom coverage within the data set. Here we have another data set. It's the Danube River in Bavaria. Here we went into another approach. Here we, for example, have seen that a combination of peak detection and waveform setting is the right approach to improve everything. So now my son is coming. 1 second. So back with you, sorry for the interruption. That was the right approach for processing the Danube River. And we just wanted to show you there are different approaches, and let's say the responsible person who is evaluating the data set needs to decide what is the right approach for getting the best out of the data sets. That was just a quick insight into full waveform processing by using the Riegl sensors and the Riegl technology behind. We believe that full waveform processing is a big chance and a big possibility, especially related to topobathymetry. And we would be pleased if you have further questions, get in contact with us. We would like to assist you guys, and hope that you also decide to go the step into digging deeper into the possibilities of Riegl datasets. Enjoy further on the virtual conference. Bye-bye.